students, we are starting with numericals of chapter 8 electromagnetic waves. In this video we will see first illustration of chapter 8. The question is, a parallel plate capacitor with circular plates of radius 1 meter has a capacitance of 1 nanofarad at time t equal to 0. It is connected for charging in series with a resistor of R equal to 1 mega ohm across 2 volt battery. Calculate the magnetic field at point P, which is halfway between the center and the periphery of plates after time t equal to 10 raised to minus 3 second. And we are given one more equation which says that the charge on capacitor at time t can be given as q of t is equal to c into v multiplied by 1 minus e raised to minus t by tau, where the time constant tau is equal to c into r. For any capacitor, when it is being charged, normally a resistor is kept in order to control current, and condition here is that suppose if this is the R and if these are the plates, let me draw a bigger diagram. The plates are circular, so if this is how the plates are arranged, then the resistor, which is R, it is 1 mega ohm, and the radius, let it be Rp. Radius of the plates is 1 meter. Now we are asked to find out magnetic field at some point P, and where is this point P? It is exactly halfway. Means here you have half meter, on the other side you have half meter, and we can always assume a circular surface through which the electric field lines are passing, and we'll consider the radius of this circular surface to be r is equal to half meter, because in order to find out magnetic field we'll need to consider a surface. So let us assume that P is on some circular surface with radius half meter. Where is this small r? Small r is radius of this imaginary surface which is between two plates of capacitor. Now which other data we are given? We are told that this capacitor is connected to a battery of 2 volt potential. Okay, and mostly role of this resistor is to limit the current, but that resistor also determines how much time the capacitor will take to charge fully, and that we can find out using RC. RC is known as time constant of the capacitor. So if you find out tau, which is equal to R into C, which happens to be 1 into 10 raised to 1 into 10 raised to 6, because it is mega ohm. Capacitance is 1 nanofarad, so 1 into 10 raised to minus 9, and then it comes out to be 10 raised to minus 3 second. Okay, let it be our result 1. Now how do we find out magnetic field at point P? So if we apply Ampere's Maxwell law, it says that closed integration B dot dl is equal to mu 0 IC plus ID. What is IC? Conduction current. As there is no charge flowing near point P, IC will be 0. Okay, and we can consider the left side to be B into 2 pi R, because we are talking about the green circle with radius half meter, so small r is the radius. Okay, and now how do we find out id? What is id? It is displacement current. So on the other side, if I take mu 0, ic is 0, and instead of id we can take epsilon 0 d phi by dt. Which phi we are talking about? Which phi it is? It is electric flux. So if we can somehow find out d phi by dt, then we can solve this problem. Now how do we find out d phi by dt? So let us label it as equation 2 and look for d phi by dt. We know that phi electric flux can be given as E dot A. Okay, and electric field in this case is sigma by epsilon 0 into A, because we are talking about electric field between two plates, so it is sigma by epsilon 0. And sigma is charge upon time. As charge is function of time, I will write q of t upon epsilon 0 into A multiplied by A. Ultimately what we get is q t by epsilon 0. This is the electric flux, and if I differentiate it, what do we get? D, no, let me write it as 1 by epsilon 0 dq by dt. Let me call it result 3. So now we have equation of charge given. Q of t is cv 1 minus e raised to minus t by tau, and we know that tau from result 1, it is 10 raised to minus 3. So if I put it in denominator, I'll get c of v as 1 minus t multiplied by 10 raised to 3. This is q, which depends on time, and then if I take q, if I differentiate this, what do we get? cv 10 raised to 3 e raised to minus t into 10 raised to 3. But at which time we want to find out the magnetic field? We want to find out magnetic field when time is 10 raised to minus 3 second. And that value, if I substitute here, what is the power of E left? So if I take this t as 10 raised to minus 3, we will be left with dq by dt as cv into 10 raised to 3 and e raised to minus 1. This is result 4. So what to do now? Now what you can do is use result 3 and 4 in 2 and simplify it. You just have to substitute values and simplify it. Say in equation 4 we have C value given, it is 10 raised to minus 9, V is 2 volt, E value you can find out. So 1 by E should be easy to calculate. Once you get dq by dt, substitute in this equation, third equation. Once you get d phi by dt, use it in second equation. What is R value? R is half meter 1 by 2. Okay, and mu 0 you are supposed to know 4.2 10 raised to minus 7. So everything is known. You should be able to calculate B value. Okay, so substitute value and carry out calculations. Thank you.